So the second part of our solving natural inequalities notes, we're just going to add some complications to this, namely having more fractions and square roots in the questions. But concept-wise, we're not really adding anything new here. To give you a nice summary of what you're looking for and when, whenever they say find the real zeros, then you're looking for the x values that make the numerator 0, only the numerator. So just take the top of any fractions you have, set it equal to 0, and solve. Those will be the real zeros you're looking for. Whenever they say, where is it undefined, that will be the x values that make the denominator 0. So you'll take the bottom of any fractions you have, set it equal to 0, and solve. Also, the other situation that causes an undefined value for x is whenever you have a radical, any values that make the inside negative. So you'll take the inside of a radical only, find out where it's less than 0, or find out when it's equal to 0, and then the negative is everything less than that. For the positive and negative sections of a graph, that's what we've been doing. We create a sign chart using all of the values determined from these other two parts. What makes the numerator 0, what makes the denominator 0. Break your sign chart into pieces, and then plug in numbers to find if it's positive or negative in between those pieces. So here's our first example with this. You can see that now we have a fraction in here, and they want to know where's the graph 0, undefined, positive, and negative. Well, we've already done the 0, positive, and negative. The only new part here really is where's this function undefined. But let's go through them one at a time. So where's the graph 0? To determine where our graph is 0, look at the numerator, x plus 1, and set it equal to 0 and solve. So in this case, my answer is -1. So for the zeros, my solution is x equals -1. Then I'm going to look for where is this graph undefined. So let's pick a different color for this to make it easier to track. So where is this graph undefined? Well, the undefined comes from what makes the denominator equal to 0. So for that, I have x plus 3 times x minus 1 equal to 0. Because remember, undefined values are what makes the denominator of a fraction equal 0. You cannot divide by 0. When you have two things being multiplied equal to 0, you can set each of them to 0 separately. This is called the zero product property. So I can say when is x plus 3 equal to 0 and when is x minus 1 equal to 0 as two different equations. This only works when you have something set equal to 0 and you're multiplying numbers together. So this first equation here, my answer is x equals -3. And for my second little equation here, I have x equals 1. So the answers for where is this graph undefined are -3 and 1. If I had any square roots in this fraction, I would also have to determine what makes the inside of the square root negative. But for fractions, you just have to figure out what makes the bottom equal to 0. So those are my two answers there. And then the last part is figuring out where is the graph either positive or negative. So for that, we make a sign chart, and I'm going to be using these numbers that we found from the previous two parts, the zeros and the undefined values. So for the positive and negative sections, I have three numbers to keep track of. The smallest number I have is -3, and then the next smallest number I have is -1, and the next smallest number I have is +1. So plugging in numbers from each of these test sections, if you plug in -4, for example, you'll have -4 plus 1 over -4 plus 3 and -4 minus 1. Well, on top, -4 plus 1, that would give me a negative number. In the bottom, a -4 plus 3 is also a negative. And I'm multiplying that by -4 minus 1 more, which is also negative. Well, a negative times a negative is positive, and then having a negative divided by a positive is still negative. So I don't care what the exact value is. If you want to be precise with the computation, you can, just to be careful. I just care about whether the graph is positive or negative, and I just determine that it's negative in that section. And then I would plug in a number between -3 and -1, so that would be -2. If I plug in -2 plus 1 over negative 2 plus 3, and then negative 2 minus 1 more. In this case, you're going to have a negative on top. In the denominator, negative 2 plus 3 is positive, and negative 2 minus 1 is negative. And rather than writing all this out, a positive times a negative is negative, and then a negative divided by a negative flips back to positive. Then I'd plug in a number in between, like 0. This one you can probably do without even writing it all out, because if you plug in zeros to all these x spots, you have a positive over a positive times a negative. Well, positive times negative is negative, and then a positive divided by negative goes back to negative. And then you would plug in the last number like 2, so you'll end up with 3 over 5 times 1. All of those numbers were positive, so this section of the graph will be positive as well. So remember, you're just plugging those numbers in and computing. You don't care about what the exact number is, you just care about positive and negative signs. So now I know where's the graph positive and negative. So if they ask me to specify these, I can say the positive sections are from negative 3 to negative 1. It's all of those numbers. And it's all of the numbers bigger than 1. And for where is the graph negative? Well, I have all the numbers less than negative 3. And I also have this section of the graph, the numbers between negative 1 and 1. So we've determined the zeros, the undefined values, the positive numbers, and the negative numbers. Now this example doesn't have a fraction in it. I wanted to do one that had a radical by itself first. So very similar, I need to identify where's the graph 0, undefined, positive, and negative. Remember, if you don't see a fraction, think of this whole thing as being over 1. So it's technically x minus 2 times the square root of x plus 1, all divided by 1. So my numerator in this case is the x minus 2 and the square root of x plus 1. If I am trying to determine the zeros in this case, so let's start with the zeros. My numerator is x minus 2 times the square root of x plus 1. So when does this stuff equal 0? Well, that means I can solve each of these separately. So I can say, when does x minus 2 equal 0? And when does the square root of x plus 1 equal 0? For the first equation, just add 2 to the opposite side. For this one, the opposite of square root is squaring. But 0 squared is still 0. So next I would subtract 1, which gives me two solutions, 2 and negative 1. So that's where my graph is equal to 0. I would list those two numbers. Next, we're going to look at where's the graph undefined. For the graph to be undefined, I either have to have a fraction, and then I want to make the denominator equal to 0, but I don't have that in this case, or I need to identify for any square roots what makes the inside of the square root negative. So in this case, I'm going to be interested in the inside of the square root, which is x plus 1. When is it less than 0? Because that would be the way we would say a negative number. I don't want these things to happen. This is what makes the square root undefined. So if I solve this, I would find that there's a problem whenever x is less than negative 1. So for everything less than negative 1, those are my undefined values. And then for positive and negative, this is where we make our sign chart again. Now our only solutions on this one were negative 1 and positive 2. So those are the two numbers I have on my sign chart. And if you try to plug in a number like negative 2, you can actually also confirm this answer just by using the sign chart. Plugging in negative 2 causes a problem right here, because I end up with negative 2 plus 1, which is negative 1, and then you can't take the square root of that. So for all of those values, this part of the function is undefined. I cannot plug in a number less than negative 1, and that's what we did algebraically over here as well. If I try to plug in a number between -1 and 2, like 0, for example, I would have 0 minus 2 times the square root of 0 plus 1. Well, 0 minus 2 is a negative number, and 0 plus 1 is 1, the square root of that being a positive 1 still. A negative times a positive gives you a negative answer. And then if I plug in a number bigger, like 3, 3 minus 2 times the square root of 3 plus 1. 3 minus 2 is a positive number, and the square root of 3 plus 1 is a positive 2. Positive times a positive gives you a positive answer. So here I can say that this graph is 0 when x equals -1 or 2. This graph is undefined for, I have it in inequality form here, but you could write it in interval notation, which is probably what the math lab will have you do. So all the numbers less than -1, that would be the numbers from -infinity to -1. And then for where is the graph positive or negative? Well, the positive section is all of the numbers bigger than 2, and the negative section of this graph is all of the numbers in between -1 and 2. So this way you've seen two tests you have to make for undefined sections. You either have to identify what values make the bottom of a fraction 0, or what makes the inside of a radical negative. So making your sign chart, you may end up with an undefined value. This especially happens a lot with the square roots, because when you try to plug in a number, you may find that the inside of it comes out to a negative. So just write undefined for those sections, and that will be your interval for an undefined part of the graph. The trickiest thing is when you combine some of those, when you have a fraction with radicals in it as well. So you have to make sure that you keep track of both restrictions. Make sure you make the denominator of the fraction 0, and make sure that you take the inside of the radical and exclude anything that makes that part negative. So we'll probably look at some examples of that in class, but that'll be all that I'll work out for the video here. Thank you.